Hello everyone, my name is Eymen Eroğlu. I'm at Ankara right now. I'm 11th grade. I was lucky enough to be with Emre'nin AI with Youth program in July. I'm currently an I'm currently a quantum computing enthusiast. I'm a more of a UAV engineering. My main field is on that. And today I would like to talk about quantum computers. My main objective will be making a clear introduce to the fundamentals of quantum computing while also looking at the emerging technologies from that field. If you're ready, then let's start. Let's start. So first of all, what is a quantum computer? In the simplest terms, in the Cambridge Dictionary, it states that quantum computer as a computer that does certain complicated uh, wait a second, I'm kind of having a problem. Complicated calculations faster than a classical computer using qubits instead of bits. And then that begs the question, what are the qubits? To put it simply, qubits are things like bits. They are same as bits, but they have one difference. Bits can be either 1 or 0, but quantum bits, qubits, can be at both values, thanks to a principle in quantum physics called superposition. And thanks to this, um, thanks to, sorry, I'm kind of having high. Uh, uh, thank, Thanks to this property, we are able to evaluate the most possibilities, and it helps us to do faster calculations than the classical computers can do. And that is the difference. So that begs the question again. We are using qubits. Now, what is the real difference between a classical computer and a quantum computer? Let me give you a great example. So the main difference is that a classical computer solves a problem by step-by-step logic. It does it solves an equation by step one. Okay, step one, it divides or adds whatever, and then does it again and again in an order. Let me give you an example about it. Let's pick a number 20. Let's pick a number. Call it 21. We say that divide this number by 2, and then uh, add the factorial of this number, and then again minus the 200. The basic classical computer will do all of these steps, perform the actions that needed for these steps in order, as I said before. But on the other hand, quantum computers doesn't need to be on that logic. They can, because of the two principles they have. One, as I said before, superposition, and the second is the entanglement. Thanks to these principles, it is able to evaluate every single possibility in that equation. And then it helps us to find the most optimal and the one answer we want. That is the quantum supremacy we call. We can also have any other examples of quantum supremacy, such as Shor's algorithm, which allows us to factor in large numbers. And when I mean large numbers, I mean huge numbers, like really huge ones. You cannot do it on your math. And also Grover's algorithm, which tells us to searching for databases. As I said before, these algorithms and the ones like them allows us to see that quantum computers have dramatically or faster than the classical computers we have. That is a plus. That is really great. But still, let's look at how they look. So as you see, I showed in the presentation before, you know what a quantum computer looks like. At least you have some ideas. As you see in here, it doesn't look like a normal laptop or even a server you have in your office. These things have thousands of qubits inside of each other. And to make those thousands of qubits to work, they need to have a perfect environment. And that environment has to be more emptier and also more colder than the outer space we have. Like imagine, you cannot make this machine work in space. You need to have a perfect environment for it to work. And then, because of this, it also has other problems. Just like the other machines, quantum machines aren't perfect. We cannot expect them to be perfect at all. But the main problems that we encounter are they're not practical. Like they do not really help us so much. And as I said before, the environment, the extreme conditions these machines work are literally impossible for both you and me to make them work. I cannot give it a space like environment to it to work in my home. It's impossible. And also it's prone for mistake. It's prone to mistakes. It can make mistakes, as I said before. But the prone for mistakes part is morely focused on the part that it's really bad about our real life problems. Like if you want to ask a real life problem to it, it won't even give you a correct answer. It will give you something out of logic. So it's useless for real life problems. But still, it doesn't change the fact that it has a great potential because, as I said before, it has a power of measuring every single possibility and finding the best. Even though they are in early stages, we can already assume that they can be used in cryptography, in chemistry, in logistics, and financial optimization, and more to come in the future if we work on them more and more. And as I said, the cryptography part, I would also like to focus on security, as most of us begs the question. So these things can do cryptography, and then that means they can crack our passwords, right? Well, thanks to the security companies, they already faked it before us. So they are now working on a technique called post-quantum. Uh, wait a second. I'm trying. Post-quantum encryption techniques. These techniques allows us to be protected from these computers. So let's just assume that one of these computers are able to crack one of our codes, one of our passwords. They can do it now, but with the work of these people, they cannot do it in later part, and they actually find a way to actually stop it, to not crack our passwords. And that is why, to sum it all up, I will say this. These machines still have a long way to go, but also not a long way to go as well, as we see the potential, but it depends on how focused we are. And we can also assume that they are at the same potential as artificial intelligence, as because they also provide the possibility factor in this part. So I can say that in the near future, I believe, they can change the entirety of industries, just to be able to do that. So that would be my point. Thank you all for listening to me. If you have any questions, I would love to answer them. You can email at artificial intelligence with teens on their own mail and also my personal mail as well. That would be all. Thank you, and I would love to see you in the next.